Hello everyone. So welcome to my lecture video for exam P1. So I'm Dr. Wang. So in this video, we will check problem 86 to 100. Okay. Okay. So this problem 86C, a city has just added 100 new people. Okay. So we're talking about all those people. So maybe such a problem like the CLT problem. Okay. Okay. So this is the city will provide a pension to each new hire who remain with the first until retire. Okay. So only remain will give this pension. Right? And if they are married, then it will give second pension. Okay, so if they drop out, no pension, right? So here we have thus at the first for each one we have two cases. 0.6 probability remain. So this is 0.4 remain and 0.6 drop, right? Okay. And for those remaining one, okay, so not married is 2.5. So here also we split into two parts: married, not married. So married is, we say married is 75, right? Or 1/3/75. So not married is 25. Okay. So we say, so for married, the pension number is 2. Not married, pension number is 1. So we can say here, pension number pension is 2. Here, pension number is 1. And the dropout pension is 0. Okay. Okay. So this is for one person. So the pension number between person to person is independent. Okay. So we want to determine the probability that the city will provide at most non-day pension for those people. Okay. So let's say for each person, the number of pension can be 2, can be 1, can be 0, right? So what is the probability that this person has 2 pension? So herself and her husband, 2 pensions, so there is probability that 0.4 multiply 0.75, right? So 0.4, 0.75, 75 3/4. So 0.4. So we can say that this is like 0.4 multiply 3/4, 0.3. Okay. And have one pension is 0.4 times 0.25. 0.4 times 0.25 is 1/4 the 0.1. Okay. Okay. Then no pension is 0.6. Right? Okay. So now what we want to find totally for those 100 people. So total numbers, let's say total equal N1 plus N2 plus N100, right? Okay, so this t will follow normal distribution. T will follow this normal. So n equal 100, 100 mu, 100 sigma square, take square root. So what is mu and sigma square? So we need a little bit calculation. So mu equal, the mean for this just mean like, so 2 times 0.3.6 plus 0.1, right? So 0.7. Okay, and sigma square. Okay, so here we need to calculate this, find the sigma square. So sigma square, let's say, so x square is 4 times 0.3 plus 1 times 0.1, right? 1 times 0.1. So, and minus 0.7 square. So this equal 1.2, 1.3. Yeah, 1.3 minus 0.49. So this is sigma square. Okay, so then so we can, okay, so this equal 70, and sigma square is, so here is equal 10 times the sigma. Yeah, 10 times the sigma. So sigma takes square root for that. So what we want to find is t at most, so less than 90. Okay, so less than 90. So equal, so changing this to standard normal, z less than, so this minus mu 20 over 10 sigma. Yeah, okay. So we need to calculate the find sigma. Yeah, take square root, find sigma, then you can check the table from this. So answer I think should be D or E, right? Yeah. Okay. So for problem 87, it says we have a sample of 48 people. So this is also maybe centrally limit. Right? We just check 48 people. Okay. So for each one, let's say for each one, so we're talking about difference between true age and rounded age. So rounded age is multiple 5. So age we just let's say age like this, 0, 5, 10. So people's age just like that. So if this guy, this person's age is like here 9, we just rounded to as 10. If there's 6, rounded to as 6. 6 rounded as 5, right? So the difference between true age and the rounded age, this difference D is for uniform distribution. Uniform distribution between negative 2.5 to positive 2.5, right? So this is for each person. Then we're talking about for those 48 people. So let's say, so here's the data is based. What is the probability that the mean for rounded age is with this year of the mean of true age? So we're talking about the bar average. Okay, we're talking about average. So this means average for those people, right? So for talking about the D bar. So D bar follow this normal mu sigma over radical A, right? Okay, so here what is mu? Mu is 0. So for this uniform distribution, mean is 0, the midpoint, and variance we have this formula. So this formula is b minus a square. So b minus a is 5. So 5 square over 12. So this is sigma. Okay, so n equal 48. Okay, so we know the average mean for all of these people, the bars distribution is follow normal distribution with mean 0. So sigma is like 5 over radical 12. Sigma over radical n 48. So use a calculator, we can find that means that's standard deviation that's. So what we want to find is such a probability. D bar is with 0.25 within 0.25, so negative 0.25. So we just want to find this probability, right? So this is normal distribution of probability. Okay, so we just changing this to standard normal, then we can find this. Okay. So for this problem 88, so this waiting time for forced claim from waiting time okay, and those waiting times are independent. So we have two waiting time, from good drive or bad drive. So therefore exponential distribution. So we just say we just put x or y. So x follow exponential distribution. This mean equals 6. So mean is 1 over lambda. Mean is equals 6. This y, so time from bad driver. So this mean 1 over mu equals 6. Okay. So what we want to find? What is the probability? So what we want to find is find this probability that forced claim from good driver will be with 3. So this means x will be less than 3 and y will be less than 2. Right? Okay. So x and y independent. So we know this probability is just equal x less than 3 times y less than 2. So here this x and y follow exponential distribution. So for exponential distribution, we have the formula, right? So this probability x less than 3 is 1 minus negative lambda. The lambda is 1 over 6, yeah, times this 3. Okay. And so here is 1 minus negative mu. Mu is 1 over 3. Yeah, 1 over 3 times 2. Okay. So this is just equal, let's say, just equal 1 minus negative half times 1 minus negative 2 over 3. Okay. So we can check what is the answer. Okay. So for problem 89, we want to find the probability that both. So both components, so we have x, y, we have two variables, are still, these components are still functioning 20 months. So this actually means we want to find that both works. So just the x larger than, so this is just like x larger than 20 and y also larger than 20, right? So we want to find this. Okay, so here, so this xy, let's see, so xy is the range for xy thus. So we should draw this xy. Okay. Okay, so we let's say, so x from 0, so we just check the letter, we change this inequality to equal. So here we have this line x equal 50 minus y. So this is x plus y equal 50. So x plus y equal 50 is this line. Okay, x plus y equal 50. Okay, so this range is x less than y, x less than y minus, let's say x less than 50 minus y. So what is this part? Okay, so we just change this to y less than 50 minus x. So here's equal y equal 50 minus x. So less than, I know, so this part, right? So there's a part. Okay, so here is 0, here 50. Okay. Okay, so now where is x larger than 20? So here we just put, okay, x, so here's 20. So x larger than 20 is this part. So y larger than 20. So here 20. So we know this integration, this part, this triangle, right? Okay. So for this triangle, so we can say like x from 20 to, so what is this part? So if y equal 20, here the x is 30. So we can say like the integration of x just from 20 to 30. So we can check out maybe B or C, right? So others D or E, 20 to 50 is not correct, right? So the check B or C. So once we have x from 20 to 30, then y from this y to this y. So from 50 minus x to 20. 20 to 50 minus x. So I think the answer is B. So from problem 10, problem 10, number, I'm sorry, number. So here we have two types of insurance policy. So we have two variables, basic or D. Okay. So this, so we put this as x and y. Okay, x, y. So this x for exponential distribution mean is 2. So we can say x for exponential distribution, so parameter lambda. So mean 1 over lambda equal 2. And the other one y for exponential distribution. So parameter is mu. So mean 1 over mu equals 3. Right? So then what do we want to find? Find the probability that next claim will be this. So this is first, like a D. So D means y. So what do we want to find is this probability. So y come first, less than x. Okay. Right? Yeah, like this. So for such a problem, that's just the integration. Yeah. So x, so let's say, so x, y from, so here x from 0 to infinity, y also from 0 to infinity. So let's check equal. So y, this is y equal x. So then, where is the range for y less than x? So less than x is this, right? This part of y less than x. So we just find it into integration for this part. So we say that this equal x from 0 to infinity, okay, dx. And then y, when we fix x, y from 0 to x, so dy, right? So then a density for the joint density function. Okay, so because those two are independent, so this is the density function for x and the density function for y. The density function for x, lambda is negative lambda x, and mu is negative mu y, so dy. Okay, so this is just this double integration. So here we just say, okay, 0 to infinity, so lambda is negative lambda x. So then this integrated out, so mu is negative mu y dy from 0 to x. So this is just the probability less than x, right? So we can use the formula. This probability is 1 minus negative mu. So this x. Okay, so dx. So this integration, so equal first one, lambda is negative lambda dx. So this is just equal 1, right? This is integration for exponential density function from x to infinity. So this is 1. Okay, lambda. Then for this integration is negative lambda plus mu x. So we have thus, let's see, is negative lambda x dx just equal 1 over lambda. Okay, so this equal 1 lambda plus mu. Okay, so here this equal just 1 minus lambda, 1 minus, so this is just mu. Here so we can regard it as formula mu lambda plus mu. So what is lambda? 1 over 6. What is mu? 1 over 3. 1 over 2, 1 over 3. So plug it in, we can find this. So for problem number 2, is what is the probability total loss is at least 1. So at the first step, we need to find what the total loss is. So here, this is like we have 2 loss. X is this loss, and collision insurance. Y is this loss. So total loss X plus Y. So what we wanted to find is this probability, right? This total loss is at least 1 or larger than 1. Yeah. Okay, so we want to find this. Okay. So what is the range for X and Y? So we say X and Y is this. X between 0 to 1. Okay, so it's X, okay, 0 to 0, 1. So for Y is from 0 to 2. So here's Y equals, so this from 0 to 2. Okay, so the range is just like this, like a tangle. Okay. Okay, so we want to find X plus Y at least 1. So let's say that's equal 1. Equal 1 is this. X plus Y equal 1. So this line is X plus Y equal 1, right? Okay, I'm sorry. So equal 1, this line. So larger than 1, so this is equal 1, so less than 1 below, larger than 1 above. So this is larger than 1. Okay, so we can find this integration, or this just or this probability, this part of probability, or just equal with the total probability 1, so just equal 1 minus this part. So we just find this part. X plus Y less than 1, right? So there's D. So we can say we just need to find this D. So fxy dx dy. So this D is, let's see. So this D is X. So from 0 to 1 dx. So what is Y? So Y from 0 to 1 minus X. So dy. So we plug in this fxy. So fxy 2x plus 2 minus y dy. So divided by 4. So we can put 4 here. Okay. So for this integration, by now it's easy, right? Yeah. So by now it's easy. Let's say we have space. So let's do one more. So equal 1 minus 1 over 4. Okay. So for this dy, so first 2x plus 1 plus 2 is constant. So this integrated out is 2x plus 2 times, so 1 minus x. Right? So minus this y. So y dy is half 1 minus x squared. So then this dx. So for this one, we need some algebra, or we want to expand, right? Okay. Okay. So problem number 2, it says we want to find the probability that the company consider the 2 bits further. So we need to check when they will consider them further. So it says the company will consider further if their difference is less than if there are two bits differ by more than by 20 or more, then they will accept the lower one. If that's quite close, then they need to consider for them more, right? So they consider for them more means that difference. So we put this as x and y. So we want to find this is just like that, x minus y. Their difference is less than 20. Okay, so we want to find this probability. Okay, so then what is the distribution for x, y? So x, y is let's say the bottom must be between this to this. Okay. Uniform. Okay, uniform. So x and y, both of them for uniform distribution. That's 2,200. Okay, so let's say. So here we put this x and y. So here's 2,000, and so x from 2,000 to 200, y. So 2200. Here also 2200. So we want to find where is x minus y less than 20. So equal x equal y. That's x equal y. So then this is okay. This is like a difference is 20. So here difference is 20. Okay. So we want to find this part. Okay. So their difference is not so big, small. Okay. So this probability equal total minus 2 over this, right? Okay. So we can change this at 1 minus 2. Suppose this is A. We say this part probability A. This part. So we just find this probability A. So A, this probability x from this point to this point. So here this is 200. This point is 220, right? So x from 220. 220 to let's say 2020. I'm sorry. Here the 2020 to 2200. So dx. So then what is y? So y, so here, what is this line? So this line we can say x minus y equal 20. Okay, x minus y equal 20. This line is x minus y equal 20. So y is so from smallest one, so from this not 0, so this is from 2 0 to large y equal x. Let's see, y equal x minus 20. Then dy. So then this density function is density function is uniform distribution. So this density function is constant. So what is this constant? Constant says constant f. So this f is actually is equal 1 over its the area for this region. So this is the 200 square, right? Okay. So we just need to find this a. So a we say this equal 220 0 dx. Then divide. So divide this. Divide from this to this. So divide is this. Let's say x minus 20. Yeah. So x minus 20 minus that. So x minus 22 this, right? So dx. So divided by the constant, yeah. So this integration, so equal, we let this equal t, so this equal from 0 to 180, like t dt. So this integration is half this square. So we can find a equal, so 200 square, then half 180 square, right? So this equal half. Just so this square 180 over 200, 180 100 over 9 over 10, right? Equal half 0.9 square. Okay, so this final answer is 1 minus, so we say answer is 1 minus 0.9 square. So problem 93, so we have two policy. Yeah, two policy. So they have two policy independent and have uniform distribution. Okay, so between 0 to 10. So x is from 0 to 10. So this y is also from 0 to 10. But there's two policy as a deductible. So for x, deductible is 1. Okay. And deductible 1. And for y, deductible 2. Okay. So payment, so benefit of payment, so equal, so here is 0, so here x minus 1, right? So here's 0, and here's y minus 2, okay? So we want to find the probability that the total payment is less than 5. So we want to find total payment. So let me say payment less than 5. So we need to check 4 cases, like x between 0 to 1, or the y between 0 to 2, so payment is 0, right? So in this case, we say it's okay, payment is 0, is less than 5. So this part of probability is 1 over 10 and 2 over 10, right? So this is x less between 0 to 1, less than 1, y less than 2. No payment. So plus, let's see. So plus x, no payment. No, 0 to 1. So x, no payment. But y has some payment. But y's payment is larger than 2. But still, so payment is less than, not 60 to 5. So payment is y minus 2. So this y minus 2 less than 5. So y less than 7, right? So this means like y between 2 and 7. So y between 2 and 7, thus, right? So also, so plus, so here we have 4 cases. So y equals 0. Y equals 0, y is less than 2. Payment for y is 0, so this is 2 over 10. Then x minus 1. So x larger than 1. X has a payment. X larger than 1. And x minus 1 less than, like x, this larger than 0, larger than 1, or less than 5. So x, so between x 1 to 6. So this is 1 to 6, so 5 over 10. Right? Then plus, both of them need to pay. So over, let's say the deductible. So let's say in this case is like x minus 1. So we have the condition x minus 1 is between larger than 0 and y minus 2 larger than 0. But so in this case, the benefit of payment is x plus 1 plus y minus 2. So this less than 5. Okay, so we need to find this part. Okay, so we have this part. So this part, so we need, so what is the probability for this part? Okay, so we need this 2-dimension, right? So here's x plus y. This is x plus y less than 8, right? Yeah. Okay, and x, this condition x larger than 1, y larger than 2. So what is this part? So we have this, let's see, so here x, y from 0 to 10. Okay, so x plus y less than 8 equal 8. So this equal 8. Okay, and also, so x larger than 1 and y larger than 2. Okay, so for this part is just this triangle. Okay, so this triangle. Okay, so what is the area for this triangle? So we say this is 1. Let's say, so here x equals 1, and this x, so this y is 2, right? So x plus y equal 8. So we can find this x equals 6. So this is 5. This triangle, this side 5. Then for y, so x equal 1. This y equals 7. So 1, 7. So this is 6. So we have this triangle like, okay. So here's 5. This is 6, right? Okay, so this area is 15. Like half 5 times 6, 15. So this equal 15 over 10 squared 100, right? Okay, so problem number 4, we need very clear. We wanted to find this T1 plus T2. So E T1 plus T2. So what is T1, T2? Okay, so T1, T2. So this is like T1, T2 is constant. The joint density function for T1 and T2 is constant over this region. Okay. Okay, so we need to schedule this region. Let's say. Okay. So here's the T1. Here's the T2. Okay. And so T1 is between 0 to 6. T2 between 0 to 6. Okay. So suppose we have this square. So here 6. And also T1 plus T2 less than 10. So let's say equal 10. So equal 10. So here's 10. Okay. So equal 10, just like suppose this line. So this is T1 plus T2 equal 10. Okay. So this region is like this, right? Okay. Okay. And the density function is constant in this region. So we want to find this is T1 plus T2. So E T1 plus T2 so equal just this suppose this region and T1 plus T2. So we put for x plus y, like x plus y dx dy, and also just multiply constant, or just 1 over this C. So what is this C? C is the total area. So total area is C. So C, let's see, C equal. So just this equals 36. 6 square, 6 times 6. There's area for square minus this triangle. So what is this triangle? So here, let's say if this equals 1 equals 6, x equals 6, then this T2 is 4. So this is 4. So this equals 2, right? So this is also 2. So this total area is 6 square minus. So this area is 2, right? Yeah, equals 34. So this problem just equal, okay? So 1 over 34. So then we just integration. So here for this integration, we have to cut it into 2 parts. So x, like we cannot say x from 0 to 6, x from this. So here, so this line, so here y equals 6, then this is 4. X equals 4, right? So there's a 0.46. Okay. So we need to have to put this into 2 parts. When x equals 0 to 4, y is from 0 to 6, right? So x plus y, so dy. So plus the other part is when x from 4 to 6, so y will be from 0 to this line, so 0 to 10 minus x. So x plus y dy. So So now for those integration, so by now is easy, right? Yeah. So we just remember for integration for y, so x constant, right? So let's do one more step. So this one, 0 to 4 dx. So here is integrated for y first. So first one, x dy. So this is just the x constant. So this y from 0 6. So this integrated out 6x, right? So plus, so y dy. So y dy is half y square. So half y square. So 6 square. So the 6. Okay. Same dx, right? So second one is the same thing. Okay, so by now we can easily do those calculations here. Okay. So problem 95 is moment generating function. So moment generating function for one variable definition is thus. Let's say moment generation for this variable x equal expectation of tx. Okay. So here we have two variables. So moment generating for two variables, moment generating for x, y. So let's see, moment generation function for two variable x, y. So here we use like st, right? So two variable. So definition equal t x plus sy. Okay, so that's okay. So if x and y independent, then we can separate as tx times ty, right? Okay. So now let's say that here we want to find moment generation for this two variable. So this moment is equal thus, right? So equal e according to the definition equal e. Okay. Okay. So T1 for first one, let's see. So T1 T1. Okay. So W. So what is W? X plus Y. So plus T2 Z. So what is Z? Z is Y minus X. Okay. So this, so we put them together. So this equal E. So X T1 minus T1 minus T2 X plus Y T1 plus T2Y. T1 plus T2Y. So this X and Y are independent. So we say this equal like T1 minus T2x. So multiply T1 plus T2y. So this become like a test moment generating function for x. So we know moment generating function for x is thus, and for y is also thus. So we just plug it in. Okay, so this equal e half of this square. So T1 minus T2 square. Okay. And for here, so this just equal e half So t squared over 2, so half over t squared. So this just become t1 minus t2 squared. Right? So simplify a little bit. We find this equal e. I think the final answer is e t1 squared plus t2 squared. So this is the answer. Okay. So okay. So for problem 96, it says he sold so many tickets, so 21 tickets. So, okay, so each one 50 cents. So we can say the revenue can be thus, right? But this is like we like at least has one do not show up, not show up. So let's say, so here we say let's say let n is number of not show up, not show up. Okay. This problem says like this bus can hold 20 people. So the bus operator or driver, he sells 21 tickets. So if this money is no refundable. Okay. So if there at least one people will not come, then everything is okay, right? So he can revenue this. But if all people come and like no one not show up, so in this case revenue become thus should minus 100, right? Should like pay, so as refund as a penalty, right? Okay, so here revenue, what is the expected value for revenue? We have two numbers, so we just find what is the probability for those things happening. So we can say this is, if this n is like this, n is at least larger than 1, then 21 multiplied 50. So if n equals 0, okay, everyone show up, then the revenue is thus. Okay, so we just need to find those probabilities. So we can say revenue can be this number, let's say 20 times 50 can be thus 1050, or can be thus, so 950, right? So the probability so that those things happen is n at least larger than 1, or we just check n equals 0. N equals 0 is what is there's a probability. N equals 0, so nobody will, so not show up happen 0. So not show up is so we totally have 21 people. So so for each person can show up or not show up. So number of show up or not show up followed by binomial distribution. So this is binomial distribution. Okay. Okay. So n equals 0 means not show up 0, 0, 2. So show up is 9, 98, right? So this actually is 98 21th power. Okay. So everyone show up. Okay. So then this is 1 minus this number. Okay. So we can find the expected value. Okay, so 97 is also like we have two variables, T1, T2. So the T1, T2, so what is joint density function? So joint density function for them is uniform over the region defined thus. So we need to find this region. Okay. Okay. So here, let's say here the T1, T2. So here T1. So what is this region? T1 less than T2. So let's say equal T2 is, let's say, so here equal, right? T1 equal T2. So T1 less than T2. So where is less than T2? So if the T2 has this is here, this part, and so T2 is less than 1. Okay. Okay. So we know. So here T2 equal 1. So the region is this part. There's a triangle. Okay. Oh, so this is L. Yeah. So from 0 to L. Okay. So we want to determine what is. We want to find the expected value of the sum of square of T1 plus T2. So we want to find this expected value for T1 square plus T2 square. We want to find this. Okay, so this is just with the integration, double integration for this region D. So T1 square plus T2 square. And the density function is constant. So we put it as a constant outside. So dt1, dt2. So just like that. So what is constant? Constant is this area. So constant is this area. So L, so half L squared. So here C actually is one of this. Yeah, C is one of this. Okay. So this is just those integration. So let's change it to x, y, not T1, T2. So let's change x to y. So that's equal 1 over half L squared. So then let's say x from 0. So we just changing T1 to x, right? X from 0 to L. So here dx. So what is y? So once we determine x, what is y? So y from x to L dy, right? So here integration the functions x squared plus y squared. So now this problem is just a double integration problem. So easy, right? Okay. So for this problem, we want to find a moment general function for this y. So we wanted to know the distribution for this y. So y equal x1 times x2 times x3. So what is the distribution for x1, x2, x3? So x1, x2, x3 follow this normal. X actually can be only 0, 1. So probability for 0 is 1 over 3. Probability for 1 is 2 over 3. So this y is also 1, 0. Right? So y is 1, 0. So when y equal 1, so only when there's 3, x1, x2, x3, both of them equal 1. So the probability for y equal 1 equal thus. Okay? And the probability for y equals 0, so equal 1 minus this, right? So like maybe we can say that's A27. Okay. Okay, so now we can say the moment generating function is very easy. So moment generating function for y according to definition equal ETY. So this y can be 0. So ET0 is 1. So this probability is 21 minus 28 over 27. So actually 19, right? Okay. So plus, so this y can be 1. So this become ET. So ET then the probability, ET then the probability that this happen is y equal 1 is A over 27. Okay. Okay. So this problem we need to calculate variance of total benefit after this revision. So we want to find a V. So total benefit. So here we have two benefit X and Y. So just like we want to find Vx plus Y, but this has been changed. So the change is X become X plus 100. So X changing to X plus 100. So for Y increase Y by 10%. So Y become 1 plus 10%, so 1.1Y. Okay, so the total benefit is X plus 10 or plus 100 plus this. So we want to find the variance for this. So X plus 100 plus 1.1Y. Okay, so this is the question, right? We want to find the variance of total benefit. So after the revision. Okay, so at first we say for variance constant is 0, so we can forget this. So this equal V X plus 1.1Y. So this equal Vx variance for y plus V 1.1y. So 1.1y V is 1.1 square thing Vy, and also plus 2 times covariance. So 2 times 1.1 is efficient 1.1 times 1. So and covariance of xy. So here Vx, we already know Vx equal, so Vx equal 5,000. We have this, right? 5,000. So we can plug in here Vx, and Vy is this. Then we want to find this covariance. So we know these things. We know Vx, Vy, and V x plus y. So vy equals us. So from here we can find the covariance. So let's say, according to the formula, what is Vx plus y? Vx plus y equal Vx plus Vy plus 2 COVXY. Okay, so plus, okay, so from here we can find this, right? We can find this. Like we know Vx, we know Vy, we know Vx plus y, then we can find the covariance for x and y. So then plug in, we can find the result. Okay, so for problem 100, so this actually is discrete distribution for two variables. So we can use a table. Let's say, like here, x, y. So we found x can be 0, 1, 2, 0, 1, 2, and y also can be 0, 1, 2, 0, 1, 2. So we put those conditions into the table. We say 0, 0 is 1 over 6, and x equal 1, y equal 0, 1 over 12. So x equal 2, y equal 0, 1 over 12. And so x equal 0, y equal 1. Here do not list, so this is 0. X equal 1, y equal 1, y over 6. X equal 2, y equal 1. X equal 2, y equal 1, 1 over 3. And so x equal 0, y equal 2. No, x equal 1, y equal 2, 0, right? So x equal 2, y equal 2, 1 over 6. So this is discrete distribution for two variables. So we want to find variance of x. So we can change this to just check x distribution. So x can be 0, 1, 2. Okay. And so here is 1 over 6. And then x equal 1 is 1 over 12 plus 1 over 6. And we find this equal 1 over 4. And so x equal 2. So just add this 3, right? 1 over 12 plus 1 over 3 plus 1 over 6. We find this equals 7 over 12. So now find the variance for x is very easy, right? Let's say like variance of x, so Vx equal ex squared minus ex squared. So what is ex squared? So ex squared equal just 1 times 1 over 4 plus 2 squared, 4 times 7 over 12. This is x squared. So minus this x is 1 times 1 over 4, 1 over 4 plus 2 times this, like 14 over 12. So that's square. Okay. So such a problem become very easy. Like, okay. So we can stop here. So this video is a little bit longer, 1 hour. But anyway, like we stop here, and so see you next video.